In these 5 examples, we're going to be using the exponent rules in order to simplify these, as well as our understanding of fractional exponents. So for number 1, we're going to be using this rule. We have an exponent raised to an exponent, so we're going to be multiplying the exponents. So I need to multiply 3/2 times 1/2. So if I take 3/2 and multiply it by 1/2, if I multiply straight across, I get 3/4. So this is 16 raised to the 3/4. And in order to simplify this, remember your denominator is your index of your root. In other words, we're taking the 4th root of 16 and then we're raising our answer to the 3rd power. So the 3 acts as a traditional exponent. So the 4th root of 16 is saying what even number can you multiply by itself 4 times and get 16, and that would be 2. But then we have to raise that to the 3rd power. So 2 to the 3rd is 8. For number 2, if you ever have a negative exponent here, ignore it for now and rewrite it as a positive exponent. So this is 36 to the 1/2, which anything raised to the 1/2 is taking the square root of that number. So the square root of 36 is 6. This would be my answer if it was a positive 1/2, but it was a negative 1/2. So how does this change my answer? I need to take 6 and find the reciprocal of that. So to make 6 a fraction, I put a 1 under it, and reciprocal means interchange the numerator and denominator, so it becomes 1/6. So my answer is 1/6. So for number 3, I have negative 64 raised to the 2/3. So again, we're going to first apply the index. The denominator, that's our index of our root. So we're taking the 3rd root of 64, and then we're raising it to the 2nd power. So this acts as our traditional exponent. And I know because there's a negative in front, that just means my answer is going to be negative. So the 3rd root of 64 is saying, what even number can I multiply by itself 3 times and get 64? That would be 4. And then I have to square that or raise it to the 2nd power, so it's 16. But again, there is a negative in front, so I know my answer is negative 16. For number 4, I notice that the numerator and denominator have the same base. The base is 8. And so if they have the same base and we're dividing, I can use this rule here that says subtract the exponents. So the base is still 8. You're not dividing the 8s. The base always stays the same. And then I'm taking 2 and subtracting 4/3 from that. So I'm going to make 2 a fraction by putting a 1 under it and then subtracting 4/3. I know in order to subtract fractions, they have to have a common denominator. So I can make the first denominator here a 3 by multiplying by 3. But if I multiply the denominator, I have to multiply the numerator. So this is 8 raised to the 6/3, again, because 2 times 3 is 6, and my denominator was 1 times 3 or 3. And then I'm subtracting 4/3 from that. So 6/3 minus 4/3 would be 2/3. So from here, I'm applying the index first, the 3rd root of 8, and then I'm raising this to the 2nd power, the traditional exponent. So the 3rd root of 8 is saying, what even number can I multiply by itself 3 times and get 8? And that's 2. And then I square that, so my answer is 4. For this last example, x raised to the negative 2/3. So ignore this negative. We'll deal with that in the very end. So rewrite it as a positive exponent. So if I turn this into root form, I know to apply this index of 3, the 3rd root of x, and then I'm raising it to the 2nd power. So when I rewrite that, I would have the 3rd root of x, and then I'm raising that to the 2nd power. That would be my answer if it was a positive 2/3, but it is a negative 2/3. So how does that change my answer? I just write the reciprocal of this. So put this over 1, and then the reciprocal just means interchange the numerator and denominator. So flip this. So my answer is 1 over the 3rd root of x raised to the 2nd power.